Hi, in this video we will discuss all about Parquet format. We will understand what makes it so special that even after a decade, no other format is able to beat it. We will start by understanding what exactly is Parquet format. We will understand what is the performance comparison of this with CSV format. We will also know what is row and columnar formats in general, and Parquet is a columnar format. Then we will look into what is inside Parquet, how exactly the data is stored inside Parquet files, so that the data is retrieved very fast and it is stored very efficiently. At the end, we will do a hands-on also, and we will see how we can read and write data in Spark. So let's get started. Let's start by understanding what exactly is Parquet. So Parquet, it is a Apache from Apache Foundation, and it is a open source format. It is a column oriented data file format. So column oriented, we will see what exactly does it mean, which is designed for efficient data storage and retrieval. So storing the data, it is very efficient, and retrieving the data also, it is very fast and very efficient. We will see more. And this format, it was developed in 2013 by some engineers from Twitter and Cloudera, and it was built on top of the work done by dog cutting. This is the person who invented Hadoop. Now let's understand why Parquet is so famous. So we will understand it by comparing it with CSV, and this data, it is shared by Databricks on their website. So let's say we have some CSV data which is whose size is 1 terabyte. Let's say 1024 GB. Same data, if we convert to Parquet, it will become just 130 GB, and it will store the exactly same data. So what that means is it will save us 87% of the storage space. So that's how efficient it is while storing the data. And in terms of query, it is very fast. So they ran some queries, and in CSV it took 230 seconds, and in Parquet it just completed in 6 seconds. So it is roughly 34 times faster than CSV. And the data retrieval, that is also very efficient here. So they tried out some queries, and while retrieving the data, when they read it from CSV, it read almost all the data, which is the 1177 GB. After like reading into memory, the size increases a bit. So it had to read entire data. But Parquet, it was able to read in a very efficient manner, and it read only the data which was required from within those files. And this time the data read was only 2.5 GB for the same requirement. So that's where it had to read 99% less data as compared to CSV. So that's how efficient it became. And because it is efficient and fast, so it saves a lot of cost. So for the same analytics in CSV, it costed $5.7, while in Parquet it was just $0.01. So it had saving about 99.7%, and who would not want to go with that much of saving? That's why it is so special. Now let's understand what makes it this special. So by default, like the CSV or JSON or other textual formats, those are row format. By row format, what it means is, let's say this is a table. So the data, it is stored row by row. Each row, it is stored together. And in this case, if we want to, let's say, read the country column only, we will have to read all the rows and then pick the third position data to get the country. So whenever some specific column are required, it makes it less efficient. And that's where the second type comes into picture, which is columnar format. So in this case, instead of storing the data row by row, it is stored column by column. So entire product column, it is stored together with some chunking, obviously. Similarly, entire country column, it is stored together. So whenever somebody is retrieving the data, if they need only country data, they will not have to read the other columns. They will be able to still read only this column from within that file. So that's the power of columnar format. And Parquet is not the only columnar format. There are others also like ORC, which was also very efficient and very famous for some time. And there are many more. But Parquet is one of the columnar format with some other additional enhancements or features. So let's understand those now. So within Parquet, the data it is stored as row groups. So instead of storing the entire column together, what they do is they create groups of rows. Let's say there are these three groups, and then within the group the data is stored column wise. Let's say these two are stored together, these two are stored together, like that. So this is a simple example where only two items are stored, but practically there are in thousands or maybe in millions also. So that's how it is very efficient. And apart from just storing the data in columnar format, like these are some row groups which are there. Let's say within the row group 0 in this example, we have product and we have country also. So within each row group, they also store a footer. This footer, it is very powerful, and this is what makes it more efficient. So it stores the metadata about the row groups and the data. It stores like their type, their encoding, their offsets, and those kind of thing. Along with this thing, the footer also contains the profiling details, like what is the minimum value of the column, what is the maximum value of the column, how many nulls are there or not. Those kind of details are also stored within footer. So if I jump to an example, let's say if I want to read only the sales amount data where the value is, let's say, greater than 200. So what it will do is it will check the file, and within the file it will first read only the statistics from this footer, and from there it will understand whether this file it has some values where sales amount is greater than 200 or not, based on the min max value. If it doesn't have, it will not even have to read the file, it will just skip that file. And if it has that that data based on those statistics, then it will read only the required column using the columnar format. That's how it will be able to read only the required data in a very efficient way. And that's the power of Parquet format. And that's what makes it very special. So now, as you understand the Parquet format, let's see how exactly we can use it and how exactly does it look like inside a file. So this is my Databricks workspace. Instead of uploading a new Parquet file, we will just convert a JSON file that we had into a Parquet format. So we will just read this JSON file first, and after that we will write it as Parquet. So how we can write is df.write.format, which is going to be Parquet, and then save it. And in the save we need to specify the location as well. So we will use like this same volume, but location we will specify separately. So instead of JSON files we will say Parquet files, maybe _2, because I may have already tried this previously. So let's write it to this particular location. So this data which it has read from JSON file, it will write it as Parquet file on this particular location. So it has written it. Now let's go and check out the data. So this is the volume, and inside the volume this is the folder which is created. Let's open it. And if you open it, this is the file which is created here. And so along with the other audit related files, it has created this Parquet file which contains our data. So as we can see, like this is the size, and if I click it, it will not be able to open it. So we will have to download it to see what is inside this. And apart from this, we also notice is like it is .snappy.parquet. So snappy, it is a compression codec used to compress the Parquet file. Snappy, it is very efficient. And here is the file which is downloaded. So let's open it in Notepad and let's see. So if we check it inside, it has many special characters and it is not human readable. So which is fine, because this is not meant to be human readable, because in Notepad we can only open text files. But what it means is that data, it is stored in a encoded form, which is very efficient while reading and writing by machines, and not much readable by humans. So this is how like it looks inside Parquet, which is not much friendly, I would say, for humans. So this is how we can write the Parquet, and this is how Parquet looks like. Now let's understand how we can read Parquet data. So reading also, it is very simple. Let's create a new data frame. Spark.read.format. Format is obviously going to be Parquet, and then .load. So this is how we will create this data frame. And after creating it, let's display the data. So here we can see that data is displayed. It is the same data, like 7 rows which were read from JSON. It has written as Parquet and it is able to read here. And also if you notice here, I have not given the path until the file. I have given until the folder. So in Spark, we can read entire folder in one go, given that the files which are inside it, those shall be of same format. So it can read all those files in one go. That's the obvious power of Spark. And in Parquet format, if you noticed, we did not use any option while reading the data. Although there are some options available, let's check them out. Here is the official documentation. And if we check it out, like there are some options which are available, which can be customized if required. But in general, I have never felt the need to customize any of this option, because whatever they have provided by default, those are the one which works best. For example, the compression Snappy, it is the best, but we can change it to any other if we want to. So in some very edge case, we may need to change something, but in general, we don't use these options. So that's what I wanted to share about Parquet. I hope you got a good idea now what exactly it is, what is inside Parquet, and how it is very efficient. So that's it for now. Thanks for watching. Bye bye.